So here we start from the outer layer. So if we look at the data center example shown here, we can just give this general equation. The P total equal to the P AC bus plus the P external. Then we can just, if we like ignore the external power source, then if we focus on the AI bus, I mean the AC bus, then we can just decompose into supporting infrastructure and IT power consumption. And if we just decompose into more detail, like finer detail, then we can just notice like the supporting infrastructure consists a lot of like auxiliary components. And also for the IT power consumption, we can just decompose into the server, the network, the storage, and all the others. Well, for sure, we particular focus is on the IT power consumption. So here, like the server, actually deal with the major computation jobs, and we just really focusing or really feel like interest on the AI side. So the AI side in a steady state, we can just use this like a rough equation to describe. We can just use the N as the number of the AI accelerators, normally it's GPU, and the peak power, like normally defined or very close to the TDP, and also the phases means like we can just separate the phase as a factor, like separate based on the pre-training, post-training, fine-tune, or inferences. So this gives us the steady state. But this is clearly not enough, right? So we more like based on Dr. Chen's introduction, like we know the AI training and running actually very dynamic. It involves a lot of like a complicated process inside. So if we look at this in a dynamic state, in a dynamic way, then the power consumed by the AI computation roughly equal to the AI accelerators. And this can be further decomposed into the compute module and the memory, the cooling, and the auxiliaries. Then the training side, actually, we can just use this roughly approximate based on the base power consumption and also the each node, like each individual calculating components. The fine tune is a little bit slightly different, but very close to the training consumption. We can just describe this as a base load plus the node, like the computation node, and multiply by this factor. This is time changing factor, like really depends on the algorithm side. The inference is more like related to the user behavior. So we can just basically use this kind of statistical description for that. And if we combine all these three stage or all the dynamics together, we can have this power consumption of AI equal to P power of training, power of fine tuning, and power of inferences. And they will multiply by a time varying factor, like based on the ratio or based on the load condition. This basically gave this very rough, like a high level mathematical description of this power consumption. And we know like this, there is much more need to do. Starting from here, we can just really dig into the training stage and the fine-tuning stage, inference stage. We can just look into like what's going on inside the algorithm, what's going on with the user behavior, and more. We just we treat this like a starting point,